Otto, are you ready to go on, even though it's 5 minutes before time?
Yeah, I think I'm ready. So I would say let's start, because then we can maybe close it already a little bit earlier and everybody can go for lunch.
Yes.
So I will try to get the presentation uploaded. Okay. So everybody seeing it?
Yes.
Good. So thank you very much. First of all, I'd like to thank Morten that he is giving us the opportunity to present our company, the Tandem Wind Energy, and our product development process during this international conference. Well, in the next 30 minutes, I'd like to present and explain our, motivation, why we are developing this small wind turbine. Then I will explain the technology of the system, the field test activities, which we are currently doing, and the next steps, what we are targeting. In order to understand our motivation, I'd like to present some facts and figures, which most of you surely will know. The global population, everybody knows it, will increase further up to 8.5 billion people in 2030. In parallel to the global energy consumption will also increase by 33% until 2040 because of this high growth emerging economies. And in order to meet this additional energy demand, we have to have in mind that the combustion of coal, oil, and gas represents, as of today, 72% of the global CO2 emissions, with the responding negative effects on our climate. And in order to meet the global targets of the global warming well below 1.5%, 1.5 degrees Celsius, we have to reduce the CO2 emissions by 45% until 2030, and to reach a zero level until 2050. So you see, with these figures, that the transition of the current energy systems is really essential to meet our climate changes. In order to, but until now, we have to see the other phase. Although renewable energy has showing dramatic increases and are representing around about 13% of the global energy production as of today, the CO2 emissions are still rising. So you see here the figures in 2019 compared to 2018, it's still an increase of 0.6%, although the investments in renewable energies is quite higher than those in fossil fuel power stations. As mentioned before, the global population as well as the energy consumption will increase, mainly in the emerging and developing countries. Currently, approximately 2 billion people have no or only temporary access to energy, and 85% of these people are living in rural areas. The impact of fossil-powered power plants for this growing energy consumption is limited, mainly because of fossil resources are limited and will get more expensive in future. Energy-related CO2 emissions and legal aspects coming out from that, and especially also in the developing countries, they often lack of the grid infrastructure. Also this morning, they have mentioned already the importance of that countries like in Africa or Southeast Asia will surpass the central power plant structures, like we have seen it in mobile telecommunication, where they also have not these classical telephone systems like we have it in Europe. So in future, energy will be generated to a large extent in these kind of small, decentralized, renewable and autonomous energy systems, like small wind turbines, but also, of course, in photovoltaic. In order to meet the requirements of the market, we have developed a robust, reliable, and affordable small wind turbine, which we want to create small wind turbines for everyone. In terms of these requirements, we are saying, okay, the requirements have to be designed for extreme climate zones. The installation has to be assembled by manpower, so we need no crane. It has to be flexible usage for mains parallel and island operations. Low maintenance cost, low operation cost is also a standard requirement for our development. And of course, in the end, a very good price-performance ratio, which we like to realize by a holistic product approach, industrial production concept, and economy of scale effect. How do we do it? So in terms of the concept, we have decided one second, I have to change here something. We have decided a downwind concept. That means we have a passive yaw system with no active control elements and reduced system complexity. So we are not using a main or an active yaw system. Additionally, we have integrated all necessary components like generator, like a two-stage gear, like shaft, and so on, in a single frame housing. That means with this concept, we can also have a very good protection against corrosion or external media. This version which you see here at the moment, this is what we are using in our field test currently. Additionally, we have a controller, a micro-based controller unit, which is determining all operation states, like start, initiating, generator 1, generator 2, and so on. It is monitoring the grid in terms of voltage, frequency, power, monitoring a safety chain. We have three elements, three switches in a safety chain concept, measuring constantly temperature, vibration, and centrifugal forces. We are using a soft starter, and we have monitoring. The controller is monitoring the braking functions. Also, we can add a remote monitoring and control functionality in our concept. The tower, we have decided to have a lattice tower, which is a very light and compact steel construction. We have it in two versions, in 12-meter freestanding and 18-meter guyed version. Both models are consisting of 3-meter elements. That means with these elements, we can build modular a 12-meter or an 80-meter. So we're using the same construction elements for this one, which makes it very, very flexible and really easy to transport. You see it already below there in the bottom. This is a 12-meter tower, which is where we put one element into the other, and you can transport it very easily. The nacelle housing, we have a fiberglass housing, which has been created by aesthetic and functional aspects by different industrial designers. And it is giving protection against sunlight and other weather conditions. And also, especially also if we talk about emerging countries, the entry of small insects. Also, it has a functionality in terms of directing airflows for the cooling of the system. Additionally, what we also consider here are branding elements that we have here enough space, visible space for using advertising and branding elements on the nacelle itself. The rotor blade is also specially developed for this concept. We are using a pultruded GFK profile, which has very good fatigue properties, high abrasion resistance, and very good UV resistance. Because it was no profile available, no NACA profile or anything like that, we have developed it especially for this purpose. And also it has been dedicated to a certain pultrusion production concept. The disadvantage is, of course, it has a very simple blade structure with a constant depth, and we have no twist with these rotor blade, but a very performance coefficient of CP of 0.43 have been reached. The blade, well, we have a horizontal axis wind turbine, 3 blades with a rotor diameter of 5.1 meter. And due to the two steps here, we have a two-step generator. We have a nominal speed of 125 and 185 RPM. Here you see a little bit how we are working with it. It's very easy to assemble. Normally 2 people can erect the wind turbine without technical support like a crane. It is setting up here by manpower. We use here a mechanical winch. Of course, an electronic winch is, electrical winch is also easier, but it also works very well. We have a very simple grid integration. We lead here the cable down from the generator to the controller, which is positioned in the 1.5 meter from the ground, and then connected to the grid. And here is a summary of the technical data of our wind turbine, of our Windstream 5. As mentioned, we have a 2-stages induction generator with a cut-in wind speed of 3.5 meter and 30.5 meter nominal wind. Power control is by passive stall downwind with a 3 yaw, 3 rotor blades, as mentioned. And for brake system, we have 2 independent electromagnetic safety brakes included in our concept. We have started the field test already. One installation is at the Folkecenter, and Morten, on Thursday I will be there. So we will test some new controller elements. So this one was the first one which we have erected here in Denmark. The second one we have erected at the university in Groningen, at Entrance it is called. Also here we have a special project running at the moment with university in Groningen as well as the university in Emden and Tandem Wind. These 3 are developing a very advanced sensor concept to measure all the behavior of the wind turbine, from the rotor blades to the tower to the nacelle. So it is an interesting project which is running here. And the third one we put here in the German Windcraft Museum. They have a test field here in Stamwede. Also there is a third pilot plant which we have erected here in Germany, and which are part of the field test which we are currently doing in order to optimize the wind turbine. What we are doing here, for example, we are testing different tilt angle, different cone angles, different angle of attack. So quite a lot of things, aligning this one to the controller and so on. So where are we and what is next? So the basic development has been completed. We are a startup company, so financing was always an important subject, but this is also finalized. The partnering of R&D and production, we also have finalized this. So a pre-series of all components have been produced and the pilot plants have been erected. Now we are in the phase of the optimization in the field. And the next step, which we are targeting or which we are starting now, is the international marketing and sales build-up and the market entry in the second quarter of 2021, where we want to deliver the product to the market. And here, maybe it's also a good opportunity here for us during this meeting. We are looking here also for distribution partners. So if one of you might be interested, we are always open for discussion. Would we welcome you. So final stage of the development is market entry, which we're targeting now. So that was a short overview how we have created our small wind turbine, what were the essential steps, and how we made our concept concrete in different aspects, from housing, of nacelle, of tower, and so on. So if you have further questions, please feel free now before we go for lunch afterwards.
Thank you very much, Otto. It has been very interesting, and you asked the reason why you were invited here, and I can tell you that it is very important that new wind turbines are coming into production and come into the market. We have seen during the past 5, 6, 7 years a lot of small wind turbine manufacturers going bankrupt and so on because of national policies around. So it's very good to see that new products can come up and that you're working with it. So therefore we welcome and also to show everybody that it is possible to come up. We saw from our last conference how Mike Berge and Berge Wind managed to reduce the costs of their wind turbines, so it was more affordable for people to get in touch with. And it was also mentioned before that the necessity of having a more price competitive wind turbine. And price competitive, that means that we have to look at the price of kilowatt hours electricity and how much you're paying for it. And what we have seen during many years is that there is a deduction in price for electricity. But thank you very much, Otto. And now I'll leave the floor open to questions for Otto. Are we having any questions? No, it seems not, even though it's, but then you can say that you made a very good presentation with all the answers. So, yeah. No, it seems as there are no further questions right now. Well, then I will say and inform you that we'll start up at 14 hours at 2 o'clock in the afternoon, European time. And that is Dr. Dorte Fouquet, who's also director of the European Renewable Energy Federation, who will give us a speech about Europe goes climate neutral next step towards 2030. And that is, of course, specialized about European conditions. But on the other hand, you can say that for the main manufacturers or a lot of the main things about the policies for renewable energy, often it is countries in Europe which are in the front there. So therefore it might be interesting, and we know that a lot of country looks at Europe, what is going on there. So therefore it could be very interesting to hear what Dorte Fouquet has to tell us. But that will be about that will be at 14 o'clock, and then we will like to say bon appetit. Now it's lunchtime.